Alright guys, a little bit more over chapter 7. One thing I want to hit upon is the idea of instance constants. I may have already mentioned the idea of anonymous objects, but it's worth mentioning again. And a few other random topics. And then I think we can wrap up chapter 7. So, I'm going to go into NetBeans. Do the usual. I believe we're on lecture H. You create an ant project. You can create whatever you want. Lecture H. I'm going to remove the package. Everything before the dot. What if I hadn't done that? I'm sure I've already shown you this in the past, but if I had, a package in there, lecture H dot lecture H. It sure is easy to remove it once you actually get into it. All you have to do is delete that line and then let NetBeans move it. So I can nuke that line. NetBeans gives me an error, incorrect package. If I click on that little red arrow, it says move class to correct folder. And there, package gone. And it is a good idea to organize your code into packages if you're creating a complex project. All right, something else I want to show you. Quick way of making classes. Now, I've already warned you to not go and willy-nilly go over here and click the error correction options if you do not know exactly what you're choosing. For example, what if I make a typo here? String, S. Control S it. And then I click over here and I do, well, there's an error there. Create class, yeah, sure, why not? Create class string in lecture H. Okay, now I have a class. Ooh, the error went away. Okay, it's clearly broken. I'm not going to be able to do things like this, right? String is equal to hello and stuff like that. Not going to work at all. Not even giving me any options to correct that. It just flat out doesn't work because you can't overload the assignment operator in Java, unlike C++. So let's get rid of that. Another example, suppose I type in scanner with all caps because I'm silly. SC equals new scanner parentheses system.in. Or maybe I forgot how to spell scanner and I just typed it with one N rather than two. And I come over here and I click on it expecting to see add the import. Well, I don't see it, so I just pick one, right? I'm going to create a class right there. Boom. It made a class. Can't say that it did a great version of it. It didn't create a constructor that would accept, that reference there. But it's ready to do that. Oh, there's the other error. It's complaining about the constructor. Alrighty. Now I have my class. Pretty awesome. It's even got a constructor now that'll accept, system.in. So when I run it, it's going to give me an exception. You can probably see why. This line right down here. So hammer and room it, green arrow it, wait for it to do all this, and when it runs it crashes. Exception and thread main unsupported operation. Okay, so what happened here? What happened is that NetBeans was happy to provide the new class. The class, it created a method for us, but in order to force us to come in and fix it, all NetBeans provided was this function here. Excuse me, this exception throwing here. And this is to make sure that we don't create, a new method and then forget to go and fill it in. All right, we're going to play with that idea just a little bit more. I'm going to delete all that. Notice what it did. Of the options I chose, it offered to create the class in several different places. I chose to create it inside lecture H. I wasn't really paying attention. I thought I'd just put it in the file, but it put it in my other class as well. And so if I cut this and paste it to make it real obvious where it is, it put a class inside of the class. That's totally acceptable. You can put classes inside of classes. You can define a class right there. You can even define a class without, giving it a name at that point. Don't think we need to do that. All right, let's delete all that. Try to fix this so that it actually compiles again. All right, but you can use that stuff to your advantage. Something like our good old point class, right? P point, just because there already is a Java class available called point, or my point. I'm going to go with P point. How about XY point? XY point P1 equals new XY point, parentheses in parentheses. All right, I can come over here and speed up the creation. Create class XY point in package, or create the class inside lecture H. Now if I do that, create it inside lecture H, it goes ahead and puts it inside this other class. I really don't recommend that. Unless you mean to do that, it's kind of even worse than throwing it in this file. Same file. Well, I don't really know if it's worse, but I should let it create it in its own file. I'm going to undo that. I'm going to come back over here and put it in its own file. I'll just deal with the fact that now we have two files going. Be good programmers for once. Click on that, create the class in the package. Alrighty. You see what it did? Created a class. See if I can get both of these going on the same page. Split screen. Alright. So if I Control S there and Control S there, it removed our error and we have a class. Okay. What if we do this? P1.x equals 2. P1.y equals 4. Semicolon. Alrighty. Create that field. What they're calling a field, we're calling instance members. Alright, P1.x. It's not set private because we're accessing it here. Do that again. Create field y. Cool. Now if we wanted to be good programmers, or at least thorough, we could then highlight those and encapsulate them. What if we wanted another constructor that would accept those 2 points? P1 equals new XY point, and we wanted to pass in a 10 and a 20, right? Well, that method certainly does not exist, but it's going to very soon. Click on that, create constructor. You see what it did? Created a new constructor. All it does right now is throw an unsupported exception. I don't want it to do that. Notice it just gave it kind of default names. These are kind of lame names. Why don't we change them to that? Int x, int y, x, this dot x equals x, this dot y equals y, like that. Now if I come back over here to my other line of code, it's complaining that the default constructor is gone. Okay, fine, let's add it. Create constructor. And there it is. Again, it's throwing an exception. I don't want it to do that. I'm not going to make the default constructor do anything. And this is the default constructor. Okay, so you see what I mean? You can kind of make a rough sketch of your class and then let NetBeans help. Let's give another example. Student S1 equals new student S1.name equals Fred, end quote. S1.id equals, 93, well, whatever, end quote. Or maybe we're going to be unique and make their student ID an int. All right, so now let's get to it. Help me, NetBeans. Make it. Create the class. All well and good. Please create that method. Excuse me. Instance member. Cool, it did. Create that instance member. Cool, it did. Add a method. S1.setGradDate, parentheses in parentheses. Whatever that's supposed to do. I don't know what it's supposed to do. It's just a sample method. Click on that, create the method. And there we go. We have the start of our class, right? Obviously set grad date. Should throw an exception. Maybe we ought to add a system.print, saying feature not supported yet. But you get the idea. Obviously, it can totally break your code if you click on these errors and then just say create class if that's not exactly what you want to be doing. But if it is exactly what you want to be doing, it can help. You can add methods to your class very quickly that way. Like if we have a line, we want a line class that accepts 2 points because that's how you define a line in geometries, by 2 points. Something like that, then we could do that pretty quickly. Line L equals new line P1 comma P1. It's going to take 2 points. We might want to calculate the distance between those two points. Double hypotenuse, hypot length, whatever, how about just hypo length, equals L dot get hypo length, parentheses in parentheses. Should calculate the distance between those 2 points. Clearly, we don't have that class. I'm going to click on it. Ooh, there already is an add import. We would need to be very careful not to choose that. So we're not gonna create the class in the package. Tab back to the lecture. It needs that method. Create that method. It didn't like it went ahead and created the class, but it did not add the parameterized constructor to support those two things. So I'm going to have to add that, click that as well, and it's going to go ahead and add that for me. Let me close XY point, I guess, and drag line over here, dock it on the side, split screen. I really don't need the student class anymore. All right. I'm going to delete all this student stuff. Coming up with errors. I must not have saved some file that I needed to save before I closed it. All right, if we take a look, our line class line, it has a constructor. It accepts 2 points, P1 and P10. How about P1 and P2? And so in order to do that, it's going to need 2 points, right? Well, let's go over here and add them. Come up here, this dot P1 equals P1, semicolon. This dot P2 equals P2, semicolon. Delete that unsupported exception. And oh no, we don't have those points. Well, of course we don't. We just added them, right? But it knows that they're supposed to be members of this class. I'm going to click on that, create that field, and then create that field. There. Awesome possum. Here we go. We now have a class that supports setting those two things. And then, well, it certainly doesn't actually calculate the length of the hypotenuse, but we could certainly do that using those points. It's rise over run. Calculate rise over run using Pythagorean theorem. Well, it's not rise over run, right? But anyways, rise and run. Calculate hypotenuse length using Pythagorean theorem. Right. That's what it ought to do. For now, just return 0. Okay. So we got the bare bones, the skeleton of our class created pretty quickly. Here's something very important here. Notice that word final. Final means const in other languages. Well, this language doesn't support the word const. Well, it seems to light up blue. It's a keyword. Have to look into what it does. Okay. What this means is that after the constructor is called, after those references are set, nothing else can change them. Right? So if get hypolink tried to change P1, B1.x equals 30, right? Something like that. It can do that just fine. But if we try to create a new reference, P1 equals new x, y, point, parentheses 5, 10, that won't work. So our line consists of 2 points, and those points cannot be changed. They're immutable. Well, they can be changed, but they can't be swapped in. If we wanted them not to be changed at all, what we should do is go back to our point class. I'm going to right-click on the point class and go navigate to source. And we could have made these final as well. Final int x, final int y. We've got something going on over here. Variable x may not have been initialized, but that's certainly true. Our default constructor should set x and y, but how about we remove the default constructor entirely? Now we have some errors back in our driver, back in our main code. So I can come back over here, and sure enough, you're not allowed to set x and y if those values are constants, right? And this constructor doesn't even work anyways because it needs parameters about if those are our values, 110. So we have 2 points. Excuse me, we have a point. We're not allowed to change these values. P1.x is equal to 10. Not going to work because this instance member is a constant. Whoops, where'd that come from? I hope that makes sense. So if you need to create objects whose values aren't going to be changed while they're being passed around, this is a fairly important idea. Because over here in line, as I've mentioned before, if you use the assignment operator to assign a reference, you're not getting a copy of an object. You're just getting another reference to it. Meaning that if I had done this, right, new xy point equals 100, and then I set x or p1.x equal to 99, then all of a sudden this object's p1 value, or p1.x, all of a sudden its x value is set to 99. Now maybe you want the object right, you know, from outside the code to be able to change the x and the y value of the points that you create. Maybe that's a cool idea. But maybe it's not, right? By assigning these, I am changing the data of my line when I may not be expecting it, right? If I went down here and did that, do you think it's cool that after I create my line, I can then go in and change the values of those points, you know, without the line really knowing about it? You know, the line picks up the effects, but P1 is not a copy of the argument that was passed in. It is the argument that was passed in. So any changes to it are reflected in the object that was created from this class. I hope that makes sense. I should be demoing using the final keyword more often. Now, on the other hand, quite often you're creating a class that needs to be able to change its data, right? You need to be able to change the instance methods, instance members. And so, yeah, you would not want to make those final. You certainly would want to encapsulate them. So if we go back to our PowerPoint, that's what we see. Sometimes you'll want an object's attribute to be fixed, to be constant. To make it constant, use the final modifier. Although a person can change his name, usually a person's name is constant, so it's fairly common to use final for a person's name attribute. I don't know, people change their names all the time. But anyways, I guess not while a program is running, perhaps. Anyways, just running with their example. Public final string name. Why is name all uppercase? Because the convention is that if you have a constant, you give it all uppercase names. So yeah, I could go back and modify my code to do that. That way, in my code, when I see this dot name, this dot name, some kind of reference to it, x equals this dot name, I know that that's something that's not going to be able to change. And I also know not to even try this kind of business because it's all in caps. I know it's a constant. I know that it's going to fail when I try to compile it. So when you use final for a variable declared at the top of a class, as we've seen, the variables can be declared at the bottom of the class, but colloquially at the top of the class is where we like to see them anyways. You're creating an instance named constant. It's a named constant, right? But it has to be set either when it is created. In order to get those values to work, to create a const, you have to set its values in one of two places. Like final, goofy, final int goofy equals 32. I can set it there, or I can set it in the constructor. That would work. I can't set it in any other method. That's why we were getting errors down here about, a while back we saw a method and it said x might be uninitialized. True, because x and y were supposed to be constants, or points p1 and p2 were supposed to be constants, and so the default constructor could not affect it. Alright, I sure do have a lot of messy code here. I'm wondering if I should just start the lecture fresh and warn people not to actually type any code for the first 23 minutes if you were going to type in code to begin with. Alright, the next thing I want to talk about is, I called it an anonymous class, or anonymous object, when I broached the idea at the very beginning of the lecture. But it's actually an object without a name binding. Right? Here we have an object and it is bound to a name. And sure, you can create multiple names that bind to the same object, right? You can create multiple references to the same object. So, although this was all useful stuff, I am going to delete all of our code in main to clear things up a little bit. Let's do the same thing we did before. Let's create a circle class that relies on a point class. The point's got an x and a y value. So I'm going to call it my point, class my point, int x. Why not make them floats, right? Double x, comma y. We're going to make them final. Once you create a point, you're not allowed to change its x and its y value, right? So in that case, we need a constructor that sets those values. Public my point, int x, comma int y, in parentheses. This dot x equals x, semicolon. This dot y equals y, semicolon. Helps if I can spell this correctly. This dot y equals y, semicolon. And then I could encapsulate x and y if I so chose. Right, just highlight that, go refactor, encapsulate fields. Now I'm going to create a circle class, which takes a my point and a radius. Right, so class circle, my point. We call the center of a circle anyways. It's origin. I'm going to call it center. My point center. But I'm going to make it final. Final my point center. So once you create it, the center cannot change. And then final double radius. And why is it complaining? Because these constants have no values. So we need to make a constructor. I hovered over the error and it said these variables are not initialized in the default constructor. Sure enough. Let's provide one. Let's provide a constructor. Public circle, parentheses. It needs to take a point. My point space center also needs to take a radius. Double radius. And this dot center equals center. This dot radius equals radius. Now, if we really want to get kind of full tilt on the idea that the object references, we don't want them to be able to change. You remember in the last lecture we provided a copy method, or a constructor that would take a new point, a new object, to create a new, create a new one from it, to clone it. Clone was the term that I used. If we did that, we could do something like this. This dot center is equal to new my point parentheses center, right? And it would create a new copy of it if we felt the need to. I'm not really feeling the need to. I think that the example works just fine without it. But if we wanted to, we could type that in. Well, why not? Why not? I can't argue for a good need for this. It's almost needless complexity, but I'm going to demonstrate it anyways. Right. And then create a constructor in my point. So I'm going to click on the error. If you're not using NetBeans for your development, you're going to just have to pause it, and do this yourself. And so when we create a new point, this dot center dot x, this dot x equals center dot x. I'd rather give it the name other though. My point other. And that way, just like the last time we wrote a clone method, clone constructor, this dot x equals other dot x, semicolon. This dot y equals other dot y, semicolon. This would be more useful, this would be more appropriate if we actually had not made these values constants. This would be a way to to separate the object that we set into another class from the original object, so that it wasn't a reference to the same object but was a new object entirely, so that they could be changed independently of one another. Alright, so that's our new constructor. It takes another point, it clones it, clone a point to construct a new point. That's what that's doing. So down here, we clone the point. Now you don't have to clone a primitive value, an int, a float, a double, you know, a string. Strings aren't primitive values, but they're just about the next closest thing because they are immutable objects, and so you don't need to clone them. You have no fear that anything can go in and change the reference or change the contents of the memory that it is referencing. All right, so we have two classes here. We have myPoint and we have circle. So down here, inside main, let's create a point that's going to represent our center. myPoint, C for center. All right, let's do C1, C2, and C3. Don't I? New myPoint C1 equals new myPoint. And the origin of this circle, I guess that's the term that I should have used up there, is 10, 10.5. Whatever. Now I can create a new circle based on that. Oh, look at that. Is that because I made them ints and they should be doubles? I sure did. X and Y are doubles, so Y is a constructor only accepting ints. Double space X. Double space Y. You saw what it did. I had to change the header to my constructor to match the data types of X and Y. Although I guess I could have just overloaded it. But anyways, down here, now that I've done that, there, I have a new circle. Excuse me. Center of circle. And then maybe R1 for the radius of the circle. The circle's going to have a radius of 20. And now let's make a new circle object. Circle, oh, well, since I did this one, I'm not liking calling this one C1 anymore because I want my circle to be called C1, so I'm just going to call this P1 for point. myPoint P1. Okay, so circle C1 equals new circle, and it takes that point and it takes that radius, right? All well and good. So we created an object named P1. We bound it to a name. Well, we created the object. It doesn't really have a name. And we say that, you know, I created an object with this name. Well, we created an object and bound it to a name. That's a strange way of saying that we gave it a reference. Right, we assigned this object's address to this reference. Different terminology. I'm not sure that the book uses the term bound to a name. But did we really have to create that object? Did we really have to make, or did we really have to give it a name? That's what I'm saying. We never use P1 again. Or what if we never use P1 again? You can create the object and pass it in as an argument without having given a name to begin with. Well, let's do that. I'm going to delete that line. And I'm going to come over here. And I'm going to, inside my argument to my constructor here, new myPoint with the coordinates of 10, 10.5. And then comma, and then the radius for it. And heck, why not just set the radius right there? All right. You would want to do that if there's no reason for you to access that point again inside your client code, in your driver code. Now, I was calling this an anonymous object because it doesn't have a name. Maybe that's a good enough term, but an anonymous class is a completely different concept having to do with inheritance, and so we're not going to do that. I'm not going to talk about that today. So let's go ahead and describe what's going on here. We are creating a new point with X and Y set to 10 and 10.5, and passing that point as an unnamed object to the constructor of the circle. We did this because the driver code, the client code has no need to track or to modify or to access the center of the circle, the center point information directly. So that's another way to avoid the idea that the client code could go in and change the value of an object when another object has a reference to it and is not expecting it to change. Because now we don't even have a name to it. How could we change? How could we change its x and its y value? Don't even have a name to get to it. We don't have a reference to it. That data is safe and sound. And it's marked as final, so nothing's going to be changing it anyways. This is not a bad idea if you're assigning things into an array. Have we talked about arrays yet? Well, hopefully you talked about arrays in your last class. An array looks like this, right? It's just a series of values. Don't type this, but if you did it in Java, excuse me, in Python, right, names, don't type this, is equal to, square bracket Joe, in bracket, in Bob, well, not in bracket, in quote, and Carol, into quote, like that, right? That's Python. This creates a list and puts 3 elements into the list. Well, in Java, you create an array like this. Int, and then you use square braces to indicate that it's an array. It's a series of values. It's not just one. Nums equals new int subscript 10 end subscript. And when I said subscript, I actually meant to say square braces, right? This is an array of length 10. It's a series that's 10 ints long, so we can put some values in it, right? Nums subscript 0 is equal to 2, so the first value in our array is a 2. Num subscript 1 is equal to 7. The second value in our array, well, I said 7, I typed 8, right? So the second value is an 8. Num subscript 2 is equal to 3, right? So the first element in an array, or the first element in a list, is always got a subscript of 0, and a subscript of 1, and a subscript of 2, and so on for the second and third elements. Now there's a short form syntax for creating arrays and specifying the values, kind of like that Python statement I showed. Int square in square nums2 equals curly braces 2, 8, 3 in curly semicolon. Right. That's a shortcut for having done it like this. There's a key difference though, because this array is only 3 elements long. This array is 10 elements long. But same idea, it's just a series of values. Once you have an array, right? Well, anyways, let's create an array of points. Just points because it's creating a circle is a little bit more complex, right? Here's an array of points. The type, my point, square in square to indicate that it's an array, not a single value. I'm going to call it plist for point list equals new my point subscript 3. Why did I type in post? My point subscript 3. All right, now it's a series of 3 points. We have room to store 3 points. Now, if we wanted to stick in, well, we don't have that point anymore. Anyway, so let's add some points to it. plist subscript 0 is equal to new my point 10, 10 in parentheses semicolon. Plist subscript 1 is equal to new my point 20, 20. Now, what if in the plist 2, yeah, typo there, we wanted to insert that first point? Well, I didn't give these names. I had a brain glitch. I'm going to make a few changes. It'd probably be easier if I just deleted them entirely, but you might not enjoy typing that. So let's do my point A equals new my point B equals new my point. I may have been happy with where that was going. I'm going to Control Z a few times and get back to where it was P list 1 and P list 0 and P list 1. So just undo until your code looks like that again if you're typing along. Now what if P list 2 needed to be a copy of P list 0? This would be one way to do it. But now we have two references to the same object. We may really not want that. But we made our point class accept a point as an argument to a constructor. So I could do this, new my point, and I want to clone the value of P list 0. But now we have two different references. We might just want to make a, no pun intended, point of always inserting copies of elements into the array. Copy objects as they're going into the array. If we were not creating unnamed objects like we were here, right? There's no way anything is going to be able to access that point except through the array, and that's cool. But if we had created the element beforehand, like I was just about to do there, let's do that. I'm going to change my point 3 to my point 4, so we have room for one more. And then my point, new point, equals new my point, and it's at coordinate 0, 0, in parentheses, semicolon. And let's put it into our list. We could do so. P list subscript 3 in subscript equals new point. Now we have two references to the same memory. We may not want that. It's safe in this case because we made them all the instance members final, but may not want to do that. In that case, we would want to do, see, we gave this a name, and then we assigned it, and that sets up the risk that we can access it via two mechanisms, two ways, right? We can access it through its array, or we can access it by name. And we could have gotten around that just by doing an anonymous object right there, an unnamed object, an object without a name item. But if for some reason we like this syntax, maybe creating a point is considerably more complex than we just want to do, you know, with an unnamed object creation like that. Then we might want to create it, you know, maybe it takes 5 lines to get our point ready, and then we want to assign it into the array. But we want it to be a copy of the original data. So P list 3 equals new my point, parentheses, new point in parentheses. There we go. Right. Now the element in the array is separate from this one. And then if we try to change, you know, the x value of the point, which we can't because we made it final, but if we could, if it had not been declared as final, then changing it here would not change it inside the array. That might be a very good thing. If you do not want the elements in the array to be changed via names that are outside of the array, it's not a bad idea to copy the elements as you're inserting them into the array. We'll see examples of that also when we move on to using array lists. The difference between an array list and an array is that an array is fixed in length. You notice when I created this array and it was only 3 elements long, I cannot go and add a 4th element until I modify it. An array list, you can just append to it, right? It grows and shrinks. All right. That line doesn't work. That's maybe about enough for this lecture. What are the concepts we've covered? One is that we covered using the NetBeans interface to speed up perhaps the development of classes, right? If my circle needed a get area method, where's my circle, right? If I wanted to print the area, double D is equal to new C1.get area subscript in subscript, it's going to complain. And then I can go and do create method. Yeah, it's not popping that up. Maybe I need to control S it. Yeah, maybe it's not going to do it at all. Well, we saw it work before. It's not working now, so I'd have to go up to the circle class and add a get area method for that to work. We already know how to do that kind of stuff. I'm surprised it didn't work. Maybe because I hadn't built it. I'm going to build it, see if that... It's funny when trying to do a shortcut takes more time than just going and modifying it would have done. So... Nope. Alrighty. Well, forget that. I'm not going to go and modify the circle class. So if you're going to turn this in, it'd be nice if you turned in both, you know, the Java class and the circle class. Oh, since it's already in the same file, no problem. Just turn in your primary class, right? I don't see any reason for you to turn in the other temporary ones that I was creating earlier if you were following along. Let's hit the PowerPoint one more time before we absolutely decide that we're done. So an instance constant, you can only assign a constant one time, and the other times are considered a, an error, syntax error. Class variables, we've already talked about class variables. May as well give an example of class variables. Say we want to keep track of how many points we have created. One way would be to come and create a class variable rather than an instance variable. Now this isn't going to be final because each time we create a new point, we're going to be incrementing this counter. So, since we can only have 1 point, 2 points, 3 points rather than 1.5, 2.5, 8.7 points, it's going to be an int. I'm going to call it count. Why not set it to 0? Not strictly necessary. Elements, non-constant elements in a class get assigned to 0 anyways, but I'm not sure that that's true for class members. And this is a class member, so we just added the word static to it. Now, every time we create a class, we create an object, we're going to increment that. Count plus plus. You don't need this reference to access a class element. Not even sure that it would count that. Might count it as a syntax error. Well, it's counting it as a warning. Don't need to do that. So now, down here at the bottom of our driver, we could keep track of how many points, or we could display how many points we've created total. Int num points is equal to, and we're going to access it to the class name, myPoint dot count. Really ought to be encapsulated and so on. So that this could only call get count, right? Rather than set count or change it, in any other way. Why don't we do that? We're going to be just a little bit thorough. We're a bit thorough on this point. It's worth talking about. It's worth talking about well. I'm going to come back up to my point class. I'm going to highlight that line. I'm going to try to encapsulate it. But I don't want to allow them to set it, so I'm only going to provide a getter. So I'm going to deselect set count. And of course it puts it above our variable list, so I'm going to cut that stuff and paste it below it. There we go. Right. Now the driver code, the client code can't set the counter, and it shouldn't be able to. Only the class should be able to keep track of how many objects have been created. All right. You need to take a look at the myPoint classes, where it stands. Here it is. Pause. Here's the rest of it. Here's the circle class. Here's the first part of our main class. And there's the rest of it. Okay, now that we have num points, we can print out how many points have been created. System.out.println parentheses quote points created so far equals space end quote plus num points. So since it was a class member, we accessed it via the name of the class. Instance members you access via the name of the instance, right? P1 dot, X, P1 dot Y, those are all instance variables. This is a class variable. It was declared as static, and so we access it to the class name. Yeah, let's run and find out how many points our code created, and it's quite a few, relatively speaking, because we were creating copies and so on up here. Yeah, we created 4 points. Yeah, I would have thought it was more than that. I'm not going to take time to worry about it, but since I see new my point, 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 to me that looks like a lot more than 4 points. I'm curious about that. But like I said, I'm not going to take the time to debug that. Is it not counting anonymous points? See, there's one of them. Why only 4? Oh, I know why. Only one of the constructors was incrementing it. We have 2 constructors, right? We have a constructor that accepts an XY coordinate, and we have a constructor that accepts a point. Only one of them was incrementing our counter, so only one way that objects were being created actually, counted as part of the counter. Now both of them will. Now when it runs, we're going to see a larger value for that. All right, 7. That looks a lot better. All right, I think this lecture is done. We need to go ahead and think about an assignment for this. So the homework involves an angle. One of the ways that an angle can be specified is the rise over the run. Right, if you have a rise of 5 feet and a run of 8.66, then you can calculate the angle. How do you do that? Well, you use the arctangent function on your scientific calculator. Now in this case, we don't really care what arctangent means. We just need to know that it's a way of calculating the angle. The way it works is 5 divided by 8.66, and then you call arctangent. That returns an amount of degrees in radians. And then you have to convert those radians into degrees that we're familiar with, 0 to 360. And if it's been a while since geometry class, that's okay. I'm actually going to give you the formula for converting rise over run to the angle. So we have an angle class. It needs 2 elements. Double rise, double run. Do not add an angle member. The angle member, no such thing. Instead, there's going to be an angle method. Calculate angle method. Get angle. Why? Because once we've declared a triangle with a rise over run, we don't want anything thinking that they can go and change the angle, right? They can't change the angle, right? Have to keep the rise over run. That's how they change the angle. So, I don't know. We could make these public. I don't care if we create getters and setters or not. If you feel like encapsulating, that's cool. Those are 2 members, instance variables. And if we were going to do good UML, then we would, specify it like this. So, for future generations' sake, preserve embarrassment. Let's do that. All right, now we need some methods. What is our method going to be? Well, we're going to create an angle, and it's going to take a rise and a run as its parameters so that we can pass those in as arguments. So the rise is a double, the run is a double. Really, I think that's the only constructor we need. I want these to be final, just for practice. We'll tack that on as a comment. Rise, the rise and run instance members should be declared as finals. All right. We're going to call that get angle, right? When you call get angle. No, this is a constructor. So there we go. Let's add a comment that this is a constructor so you don't get confused just like I did. And now we need a method called Calc Angle. It's going to return value between 0 and 260. Might be fractional, probably will be, so we're going to make it a double. Get angle. Get angle is going to use the rise over the run to convert that to degrees, between 0 and 360. And why not? Let's calculate the hypotenuse. We already done this, and we already calculated the hypotenuse today. Back in this semester. Am I spelling that correctly? Hypotenuse. Looks like I may have gotten it correct. Take a look. Nope. There we go. So we need to get hypotenuse. I'm pretty sure that we've done this already. But we're going to need the formula for hypotenuse as well. I could make y'all research it, right? Formula for hypotenuse. Is that square root of a squared plus b squared. So we'll want to use the math.sqrt function and the math.pow function or something like that. So, make the assignment a bit less mathy. Here's the code for get angle. And I already wrote it up here. I'm just going to copy and paste that. Formula for get hypotenuse is hypotenuse is equal to the square root of rise squared plus run squared. All right, that makes sense. Then your code just needs to create a few angles, about 2, and print out their hypotenuse and their angles. To make it slightly more interesting, we're going to add one more constructor, which takes an angle. I'm going to call that a copy constructor. There we go. I hope that makes sense. If not, ask me for help. Shouldn't be too difficult. All you're going to have to do is, oh, see, there we go again. I get in the habit of declaring these in the wrong fashion. I give you the formulas right? I gave you the entire chunk of code for get angle. I gave you the formula for get hypotenuse. Maybe we should call it get angle in degrees. That'd be a little bit more accurate. All right, I think we're done. I think that's the assignment. I'm going to go and move this comment about make them final. The rise and the run should get declared as final. And by the way, just to test it, make the rise and the run of an angle equal to each other. And then the degrees will be 45. Right. If it's 45 forward, 45 up, that's a, excuse me, you know, if it's 100 forward, 100 up, that's a 45-degree angle. It's just the way angles work. Then create the other angle as a copy of the first using the copy constructor. All right. Feel free to encapsulate the variables. All righty. Contact me if you have questions.